In this video, we are going to look at a situation involving a quadratic equation in vertex form. I'll read the situation and then the questions, and we'll go from there. So, Indigo throws a stone from a pier into the ocean below. The stone's height, measured in meters above the water, x seconds after he threw it, is modeled by the following equation. H of x is equal to -5 times x subtract 1, quantity squared, plus 45. Now the questions. What is the maximum height that the stone will reach, and after how many seconds will it reach the water? So let's look at the first question first. What is the maximum height? Well, I could do that better. What is the maximum height that the stone will reach? Now remember, the maximum height for a parabola that is opening down, in other words, a parabola that looks like this, the maximum height is going to be the vertex. And so we just need to find the vertex, and that will tell us the maximum height that the stone reaches. Now the handy thing about this equation and the form that it's in is that it's already in vertex form. And so if we know how to interpret a quadratic in vertex form, then we will be able to say, or we'll be able to determine what the maximum height that the stone reaches is. And so vertex form, I'll write it down here, vertex form looks like this. We have y is equal to a times x subtract h, quantity squared, plus k. And our vertex is at h comma k. Those are the x and y coordinates of our vertex. And so just to be clear here, we are not including the negative in front of the h, just the h itself and the k, okay? And so if we had x subtract 3 in here, then we would substitute 3 in for the x coordinate there. Okay, let me remove those so that's a little bit clearer. And so our vertex is at h comma k. And so if we look at this equation here, if we look at the equation that we're given, then we can see the vertex already. The vertex is at the point 1 comma 45. So 1, this part right here, 1 and 45. Those are the coordinates of our vertex, and I'll write them in green here just to highlight that these are the actual values of the vertex of our parabola. The x value is 1 and the y value is 45. And so if we remember that time is measured in seconds and that the variable x represents time, then we know that this, I'll do this in yellow here, this is the number of seconds. This is the number of seconds. So 1 second after throwing the stone is when it reaches its maximum height. And this right here is the maximum height itself. This is the height in let's see, was it meters or feet? In meters. This is the height in meters above the water that the stone reached at its vertex. And so that is that's our vertex. We can mark that on our graph here. So we have a point at 145. So we go over 1 and then up 45, which is right here. That is the vertex, or the highest point of our parabola. And since the vertex always lies on the axis of symmetry, I can draw out the axis of symmetry here also. So the axis of symmetry is going to be at x is equal to 1. And so I can put that right on x is equal to 1. And now I see that I've actually drawn my vertex off to the side a little bit. So let me fix that. So our vertex would actually be right here. Probably not a bad idea to start with the line of symmetry or the axis of symmetry and then draw your vertex on top of it. So we just in looking at the equation itself, we've figured out what the maximum height was. The maximum height, I'll do this in yellow, the maximum height that the stone reaches is 45 meters. 45 meters. So the next thing that we need to figure out is after how many seconds will it reach the water? After how many seconds will the stone reach the water? So you can imagine that the stone, that we have some y-intercept, that we'll calculate what that is, but we have some y-intercept, And as time goes forward, the stone is going up, it reaches its vertex, and then it's going back down again. And this line down here, the x-axis, is where y is equal to 0. That's the surface of the water. So we want to find out after how many seconds, or what will the x value be when that stone reaches the water. We don't know what that is yet. I've just sketched this out as a guess maybe. So I'm going to delete this and we'll actually calculate it out. So here we go. All right, so when will the stone reach the water? Well, what is the y value when the stone reaches the water? It's going to be right at this x-axis here. And so the y value when the stone reaches the water is 0. The y value is 0 when the stone reaches the water. So we are finding the x-intercept. We're finding the x-intercept, and the x-intercept y is equal to 0, just like I just said. So in order to find out what x is equal to when y is equal to 0, we can just replace h of x here, which is our y value. We can replace that with 0. So we have 0 is equal to, and then I just rewrite this here. 0 is equal to -5 times x subtract 1 squared plus 45. So we know that y is equal to 0 because that's when the stone hits the water. We don't know how many seconds it takes for that to happen. That's what we need to solve for x in order to find out. So let's go ahead and solve this for x. If I subtract 45 from both sides, then I will have 45 is equal to -5 times x subtract 1 quantity squared. And the next thing that I want to do is divide both sides by -5. So 45 divided by -5, we have, actually I've made a mistake here. 0 subtract 45 is -45. There we go. So -45 divided by -5 is 9. And on the right-hand side, -5 divided by -5 is equal to 1. And so we are left with just x subtract 1 quantity squared. X subtract 1 quantity squared. And so now we can take the square root of both sides here. And so that will give me square root of 9 is equal to the square root of x subtract 1 quantity squared. And so what's the square root of 9? Well, it's plus or minus 3, because -3 times -3 equals 9, and +3 times +3 also equals 9. And then our square, our exponent and our square root sign, those are opposite operations. And so the right-hand side simplifies to just x subtract 1. So now we have two separate versions of this equation that we need to solve. One where 3 is positive and one where 3 is negative. So we'll put our +3 version on the left and our -3 version on the right, and switch back to green, and here we go. So +3 is equal to x subtract 1. If we add 1 to both sides, then we have that x is equal to 4. So that's one of our solutions. And then our other solution here, we have -3. -3 is equal to x subtract 1. And then if I add 1 to both sides, then I get -2 is equal to x. So these are my two solutions to this equation here. And the application of this is that these are my x-intercepts. That's what I was trying to find. Remember, y was equal to 0, which meant that I was somewhere on the x-axis. I just didn't know where. But then we solved for x, and that told us that our x-intercepts, so again, when y is equal to 0, are at x is equal to 4 and x is equal to -2. So let's go ahead and plot those. X is equal to 4, and then x is equal to -2 would be, somewhere just past the end here. But a quick but very important point: this equation only models the trajectory or the stone's height. It only models the stone's height when x is positive. So if you think about it, like just because we could graph this back down to this line here, does that mean that 1 second before Indigo threw the stone, that it was at the surface of the water? No, we don't know what happened before he threw the stone. And so this equation here only models from this point going forward. Okay, it only models from 0 seconds forward. And so this x-intercept of -2 is basically meaningless to us right now, because we're not modeling the time in the past. We're only modeling from when the stone was thrown. Okay, so long story short, we only care about this x-intercept here at x is equal to 4, and that's also the answer to this question here. When does it reach the water? Well, it reaches the water, or y is equal to 0, when x is equal to 4. And so let me write that out. That is at 4 seconds, or 4 seconds after throwing the stone. Okay, I would really like to finish graphing this. Even though we've answered our 2 questions here, let's graph this this parabola so we can actually see not the path that it takes through space, but how the height of the rock relates to the time after it was thrown. So we only need one more piece of information here. That piece of information is the y-intercept. We don't know exactly where it crosses the y-axis, so let's figure that out. So we have our y-intercept, and our y-intercept is just going to be wherever x is equal to 0. So our y-intercept is where x is equal to 0, in the same way that our x-intercept is where y is equal to 0. These are the same idea, just flipped. And so in order to find out what our y-intercept is, all we have to do is substitute in 0 for x. And so that's what I'll do here. We have h of 0, because I'm substituting in 0 for x, is equal to -5 times 0 subtract 1. Well, I can write this a little clearer. 0 subtract 1 quantity squared plus 45. Okay, on the right-hand side here, 0 subtract 1 is equal to -1. So we have -5 times -1 squared plus 45. And then -1 times -1, or -1 squared, is +1. And so we're left with just -5 times 1, which is equal to -5, plus 45. And then -5 plus 45 is equal to 40. And so our y-intercept, in other words, when x is equal to 0, that's at 40 meters. Yeah, 40 meters. Okay, so let's mark that on our graph here. So 40 meters right there. And then we can graph this. So we have our parabola here, starts at 40 meters, goes up to our vertex at 45, and then continues. Ooh, let me try that again. Realized I was off the path. I need to get all the way down to, that's not great either. Really want to be accurate here. The vertex really needs to be the highest point. Okay, I've got that. And then we're going to go down until we, oh, there it is, perfect. As we go through our x-intercept there after 4 seconds. Okay, so this is the parabola that models this equation. This equation models the stone as it's thrown from the pier, and I'm realizing now that 45 meters is a really tall pier. So maybe it's more accurate to call this like a cliff or something. This is threw it from a cliff into the ocean below. That's minor detail maybe. So again, this is an equation in vertex form. Vertex form describes the vertex of the parabola, and so we can pull the vertex out of it very easily. And then once we find the x-intercept and the y-intercept, then we have enough information to graph our parabola. And again, I don't continue the parabola down in this direction here, because negative seconds or the past, this equation is not modeling the past. We're only modeling from the point at which he threw the stone, which was at 0 seconds, and counting forward.